My head is so congested. Gentlemen, what we're here to talk to you guys about today is H2x4 Hornet, which is a fairly well constructed HG amplifier. It's 2 drive and 4. This screams at me fat boy, this whole thing. But then there's stuff in here that is definitely not fat boy, like this and this and this and some of this. But the biasing circuit is very fat boy-ish. Okay. The relay is in here floating, but now I called and I talked with the customer last week. He wants me to do the full meal deal to it. He wants me to, let's see, what do we got for a fan? It's got a decent little sun on in it. He wants lights in it. He wants Toshibas in it. He wants the power wire upgrade. He wants everything. So what we're gonna do is rip it apart, rip the pills out of it, which are just HG 16D08s. And we're gonna pull the relay out, put new tape on it, get this thing secured, because having this flop around is no go. Metal clad, output tuning capacitor, that kind of stuff. So away we go. Okay. Let's take a quick minute. What we're gonna look at is the signal coming out of the network analyzer, through the coax connector, through the relay, and out to the dummy load. Let's go ahead and fire this up. Not too hot. Okay. So right now we've got a 1.3 SWR rising to a 1.8 SWR. Let's take this 30 puff capacitor. First off, let's tell this to run. Let's see if we can get this leg to I think we might be onto something. What do you think? So we went ahead and we soldered in this capacitor on the relay. Right. Yeah. Now we'll tell it to run again. Poof. Now what we've done here is we've made it so that you can talk through this box with absolutely no restraint. But more importantly, we made it so that we can hear through the amplifier with no restraint. So the RF coming back from your antenna isn't seeing a 1.3, 1.4 SWR before it gets to your radio. It's seeing next to nothing. So vastly increased your ability to hear. Yeah. Well, I got busy on the phone. Today has been a rough day. I'm not gonna lie. So let's go on in here. So you got a match set of Toshibas in here. Yeah, these are the real deals. Match set of 6, what are these? 6A Toshibas. And I don't think I got a match set, but they were both new. 7B and 8E 2290s drivers. So basically replace the HGs, give it the power wire upgrade, change the bias circuit around. We fixed the relay, fixed the sideband delay. Relay's in there now. So about the only thing I got really left to do, and I'm sorry that this video is so short. I could have sat here and talked half the afternoon, but I ended up being on the phone. Seems like everybody around me right now is having all kinds of personal crises. My attention was not on making YouTube videos today. I was trying to help everybody with all their problems. The only thing I got left to do is customer states you'd like to have an Anderson clip installed. So I'm going to throw the Anderson clip on the end of this wire here real quick. And then he wants me to put some green LEDs in it. So we'll put some green LEDs on the lid shooting down. It'll reflect back, make the fan glow nice and green for him, real pretty. We'll get that installed here real quick, get this on, and then I'm going to put power to it. I want to test my bias circuit, and then we'll bring our bias chokes into play, and this thing will be full class B, ready to go for sideband. So, on that note, give me just a minute, and when we come back, we'll be ready to go. Just listen to it. This is one of those rare days of the year where it's like perfect outside. It's just cool enough to pull all the heat out of the house and the shop and everything, and it's like, it's one of them days where you could go stand outside and go work on your truck all day, and you're like, God, I wish it was like this all year long. There's no roaring fans, there's no, it's just quiet. Listen to this. Let's come over here. Let's take a quick look at this. So first off, we're going to start off in 12 volts. It's a 1,000 watt slug, 1,000 in average. This one's in peak, of course, 1,000 in average, or bird, or RMS. However you guys want to nitpick it apart. 5 watt slug in reverse. It's just a 1,000 watt element with no amplification to the signal going forward. We are on 12 volts. The amplifier is off. It's got green LEDs for the switches. Oh, we upgraded the switches on the sideband side of life so that when we flip on one switch, we only have one that comes on and not both, which is not that hard. It's really not. It's, you go to a double pull, double throw switch, just so the guy that built this, if he ever watches this, just so you know, you go to a double pull, double throw switch. You bring your positive circuit in here. Then you take your output circuit and you tie that to your LED, and then the actual output lead, which is on a broken connection, goes back over to your capacitor. But to keep it backfeeding, or voltage leaking through the capacitor back to the LED and completing the circuit back to ground, you have to put that also on a switch. So we take the two top terminals and jump them together. That's all there is to it. It's not rocket science. It's not. Okay, now I gotta move the camera back over here because I've gotta turn the power supply on here in a second. So let's show you guys drive here real quick. Now, every once in a while, and this is a known phenomenon, if I take and build 10 2-pills, let's say, I build 10 2-pills. Every single one of them has the exact same component with the exact same gains to it, exact same capacitors, exact same leg length on the capacitors. They're all within a 1% tolerance of each other. The power wires are all the same. The drive level is all the same. Everything's the same. And you take that 10. This one over here, we'll say a 2-pill. The 2-pill, 500 watts. This one's going to do 480. This one's going to do 490. This one's going to do 505. This one's going to do 490. And then you'll have one over here that does like 530. It's just a little bit hotter. I've discussed this with every amp builder on the face of the earth, and they all agree it's just part of the laws of average, right? So you always end up having one that's just a little bit hotter than the rest. This is a hot box. I say this, when I have one of these come along, this isn't your average 2x4. 30 watts, max. Anything over that and you're going to start blowing pills out of it. And I mean 30 watts peak envelope power. It's keyed up. Hello, audio. You're going to have a 1 watt dead key. 1 watt dead key. Anything more than that, you're going to pop this amp because it's so hot. And I mean, this thing makes a ton of jizz. So we're going to take our 5 watt slug and we're going to set it so it's forward reading. We're going to put exactly a watt. It's 1 watt going forward now. It's 1 watt going forward to the dummy load. We're going to turn this back around. So over here is a 1,000 watt slug in, right here is 1,000 watts in peak. Hello, 1, 2. Check this out. Turn the amp on. 1 watt dead key gets us 150 watt dead key going out. So no more than 1 watt going in. Hello. That's 825 watts worth of peak power with 20 watts of drive. You put 30 in it, you're going to get almost 1,000, and that's at 12 volts. Hello. Okay. Let me show you what I mean. Now the voltmeter on the face of the power supply, at least last night when I was totally farting around with this, had it trimmed to exactly 14 volts. Okay. There's 14.1 volts. Less than what you're going to have in your car. So at 14.1 volts, we turn the amplifier off. Barely 20 watts of drive once again. Watch what happens with this amp. On 14.1 volts, 20 watts of drive. 200 watt carrier now. So let's double check how much drive we're putting into this thing. Turn the amp off. 1 watt. That's 1 watt. Turn the amp on. Turn the element back around. 200 watt carrier. Off the chart. Re-emphasize this. About 1200 watts. Now we're going to go to 2x. This mark right here is 1,000 watts. Next major graduated hash mark, 12, 14, 16, 18, 2000. Okay? We're going to end up right about here. Now this is full class B bias. Hello, 1, 2. Hello, 1, 2. Now from the angle I'm standing, that looks like 1200 watts. From the side angle that you're looking at it, you're seeing about maybe 1800. That is a lot out of these 4 Toshibas. I'll bring you over here to the angle that I'm standing at. I'll show you what I mean. Hello. The big hash mark between the 40 and the 60 is 1,000 watts. And that's with 20 watts of drive. So the guy that owns this box, don't go and put a striker in this. Don't go and put, I mean, this is a Cobra 29, a Cobra 25, and you don't want it to do more than 30 watts max drive. That's 1 watt carrier modulated to 30 watts, not a 30 watt dead key. Hello. 132 amps. Now this is on AM. So I can move around, I gotta put the camera over here. Let's go ahead and we're gonna turn on the sideband delay. And we're first gonna demonstrate sideband delay on AM. So just listen. We can hear the relay popping in the amplifier. Let's turn on sideband delay. You see that slow delayed reaction? That's because of this capacitor. So now let's run it on sideband. Hello, 1 2 1 2 1 2 1 2 1 2 1 2 audio 1 2 1 2 1 2 1 2. I had a nice guy ask me the other day in my group, BBI Amps, the group. He goes, hey, BBI, why don't you ever show the amps running in sideband? And I'm like, in my mind, you know, because sorry you guys, I'm an amp builder. And I look at everything in the amplifier world from the amp builder's point of view. There's no point, okay? Let's look at the peak number. So let's go back over to AM. Dead key in 1 watt again. Hello, 1 2. Okay. Now we're going to go to sideband. Hello, 1, 2, 1, 2, 1, 2. Does the same amount of power. So it's a double redundancy test. The amp produces the same amount of power on AM as it does on sideband. What does change though drastically is the amp current draw. Let's look at that. Here we are in AM. Hello, 1, 2, 1, 2. Okay. 130-ish. Sideband. Hello, 1, 2, 1, 2, 1, 2. Now, I gotta quit being cocky. I gotta quit operating the amp because there's no air on this box. And it's working as hard as it possibly can. These transistors are getting hit with so much shmoo. I mean, we're running a ragged edge. 202 versus 130 amps. It's the only difference. So nothing changes on the workbench. The output power stays the same AM or sideband, for the most part. But he pointed it out and I thought, you know what? I'll take your point of entry and I'll squirrel it away in the back of my brain. So now, we've got to stop running this just for a minute. I got to unplug this. And we need to bring this into the equation. We want to put air on the inside of this cabinet. Now, the reason I'm showing you this is because of the super LED strips that I put in here. This guy likes green. Green is good. I like green. Makes me have happy spots in my shorts sometimes. No, it doesn't. No, it doesn't. I'm just talking out my butthole. Let's go in here and solder you to this little guy, and let's get some more solder, as Mr. Carlson puts it. And yes, you guys, I am familiar with Mr. Carlson's lab. I enjoy his program. He's a very smart, knowledgeable man. I've been following along with the new build of the Super Lab. I think it's freaking sweet. I think it's great that he's been so successful in his adventures between YouTube and his other adventures that he has going on, that he can afford to build himself a super lab. I would like to build myself a super lab someday. I can keep dreaming. That's why I keep saying, keep subscribing, keep sharing. Let's throw some screws in this thing so we got a good ground going on here. Oh. Boy, this cold I got last week has been no joke. I mean, it's already Thursday. Aren't you going to slide? Why is she going? There you go. Oh, no. Okay, here we go. You know what? I don't like that. What are we catching on? All right. Okay. For me to keep running the amp, I got to put air on it. And normally I keep kind of like a little mental index. Okay, you've keyed it like 10, 15 times now. Got to slow down and let it cool off. Well, yeah. I misjudged that the other day and actually popped a pill on camera, and that was 100% my fault. It was, and I embrace it fully. That's the reason I left the segment of video in there. Because what happens here, it happens here. It's okay. This is the place things come to get healed. I just put a couple transistors in the guy's amp and we went on with our day. That thing glows green now, plus we got the advantage of good airflow. And yeah, this thing's warm. Let's give it a minute. Let me let this thing just cool off, and I'm going to go ahead and put the rest of the screws in it. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Hello, 1, 2. Last thing I want to show is the input tune. This amp is so hot there is actually an attenuator in it, so the input tune is going to be righteous. 5-watt slug and reverse between the bench 2950 and the 2x4. Hello, 1, 2. Hello, 1, 2. So we're making all that kind of power with an attenuator in line too. Hello, 1, 2, 1, 2, 1, 2. That's not nearly as impressive as when we have it on the 1000 watt scale, I think, just me personally. Hello, 1, 2, 1, 2, 1, 2. Hello. I mean, as much as a fan as I am of the next guy is slamming the needle on the stop peg. Keep an eye on your air temperatures on this deal. Keep an eye on your air temperatures. And please don't overdrive this, because it won't take much. You overdrive this and this thing's gonna go bang, Mr. M. It's literally got every good part that money can buy in it, to our knowledge to date. I mean that seriously. You spent the money, you've got the good pills in it, okay? Good transistors. You've got the good bias circuit, the best that we've been able to figure out to date. And I'll debate that with anybody any day. The only thing that we can do other that would be better than this, with the least amount of, the best bias that we can figure out to date with the least amount of parts that aren't computerized. Throw this up here. Because there's a form of digital bias that we can apply, and there's also a form of censored bias that we could input into this thing that works off of temperature, voltage, ambient air parameters, heat sink temperature, thermal coupling, and a bunch of other shit. Yes, it's slightly better. Yes, we can achieve a slightly tighter mode of operation, but putting an Arduino computer with like 6 or 7 different thermocouples attached to shit inside this thing, no one's willing to pay for that. So this is the best of the best of the simplest technology that we can come up with. And what I found with the amplifiers, it comes down to simplicity is king. The more simple that you can make the circuit, the longer it's going to last. Low drive. Please, low drive. On that note, I don't think I got anything left I got to check. Well, gentlemen, my name is BBI. I am the lucky duck plucker that gets to work on all your guys' stuff. And I thank you for the opportunity on it. And on that note, I got to run. My godkids are here, and they take off in a couple days, so I'm going to go spend the evening with them. But thanks for watching. On to the next project. We'll see ya. Click, click, click.